Hi everybody. In this video, I have decided to share some answers of a past paper question that was on standard costing. Standard costing is one routine area that they test questions, but then why I have selected this particular question, there is a slight difference in the requirement where you have to find variances mixed up a little bit with the ABC principles where they are talking about machine setup cost. And on machine setup cost, they ask you to find the expenditure variance and efficiency variance. So usually in F5, when it comes to variances, mix variance, yield variance for material, labor, sales mix variance, sales quantity variance, planning variance, operational variances, all these variances you must be very familiar with. But then this kind of variance is where ABC is mixed, and using ABC principles and standard costing finding a variance could be a little unfamiliar for you. So that's why I thought I'll take this example. This is a past paper question, and I will explain you how to tackle questions like that. Let me read the question first. Choco is a company which manufactures and sells three types of biscuits in packets. One of them is called ooze and contains three types of sweeteners: honey, sugar, and syrup. The standard materials usage and cost for 1 unit of ooze, that is 1 packet of ooze, is as follows: honey, sugar, and syrup 20 grams, 15 grams, 10 grams with prices and the cost given. In the 3 months ended 30th November 2011, Choco produced 101,000 units of ooze using 2,200 kilograms of honey, 1,400 kilograms of sugar, and 1,050 kilograms of syrup. Note, there are 1,000 grams in a kilogram. Choco has used activity-based costing to allocate its overheads for a number of years. One of its main overheads is machine setup cost. In the 3 months ended 30th November 2011, the following information was available in relation to setup cost. Budget. Total number of units produced 264,000. Total number of setups 330. Total setup cost 52,800. Actual total number of units produced 320,000. Total number of setups 360. Total setup cost 60,000. Calculate the following variances for materials in ooze: usage variance, mix variance, quantity variance, or yield variance. These are three usual variances: 4 marks, 4 marks, 4 marks each, 12 marks. If you see this question, you must be very happy. There's just a standard format of working. You're just going to apply, plug in the numbers, and get the answer. Mix variance. How do we do mix variance? Let me start here. Standard quantity for actual production. Actual quantity used. Standard price. Here what you will do is bracket standard quantity minus actual quantity multiplied by standard price, which will be the usage variance. Right. Material types, you have honey, sugar, and syrup. Standard quantity for actual production. Actual production, how many units? 101,000 units of ooze was produced here. 101,000 units. So 101,000 multiplied by standard usage 20 grams. 20 grams multiplied by 1000 to make it kilograms. Sugar 101,000. Don't forget the standard quantity. SQ refers to standard allowance of material for actual production. So you must multiply the standard usage and actual production to get that figure. Don't forget that. I always emphasize on that. 15 grams is the standard. That is the kilograms. 101,000 multiplied by 10 grams, 1000 to convert that to kilograms. I forgot the equal sign. Doesn't give you the answer. Equal. Actual quantities used: 2,200 kilograms of honey, 1,400 kilograms of sugar, and 1,050 kilograms of syrup. Standard price is 0.02 per kilo. Per gram. I have done the question in kilograms. So here the standard price I have to convert to per kilogram, because remember this is in kilogram, this is in kilogram. The difference you're going to get is in kilogram. So the price has to be per kilogram. If 1 gram is 0.02 per kilogram, it has to be multiplied by 1000. 0.03 is 1000. 0.025 is 1000. So that's the per kilogram price, equal bracket this minus this close bracket multiplied by standard price. Done. Drag it, equals this plus this plus this, or you could have used a sum function also. This is what you call total material mix variance. 1150 adverse. 1150 adverse. Done. They don't ask for the interpretation, they have asked you to do the calculation only. Done. Next part, they asked you to find the, sorry, it's not the mix variance, I made my mistake, apologies. It's not the mix variance, total material usage variance. Usage variance. Done. Second part they asked is to find the mix variance. So here you could have given a heading, material usage variance. Not necessary for formatting, just to help me going through this easily. Material mix variance. Material mix variance. The format. What is the mix variance format? Honey, sugar, and syrup. Actual quantity at standard mix. Actual quantity at actual mix. The difference. Standard price. Mix variance. Total mix variance. The spaces you want to adjust, select all these columns, double click on one of those column border columns will get adjusted automatically. Actual quantity at actual mix, you already have it here guys. This is the actual quantity at actual mix, so I can directly connect it there. I don't have to retype it again. Just drag it. So those three comes. I need the total, so maybe I can use a sum function, equals sum. That's the total amount of material that has been used. This material, if it was used according to the standard mix. What is the standard mix? Standard mix is 20, 15, 10. 20, 15, 10. 20 divided by 20, 15, 10 is 45. Equals total multiplied by 15 divided by 45. Equal total multiplied by 10 divided by 45. 20, 15, 10 is the ratio. Let me adjust this to 2 decimals. The difference, standard mix minus actual mix. Difference. Standard price, we have it here. Just copy one figure and drag it correctly, or else you retype it, no problem, whichever saves time for you, do it. Mix variance is difference multiplied by standard price. Difference multiplied by standard price. So the total mix variance has to be the sum of these three. So your total mix variance is 1416.67. Since the answer is positive, favorable. If you want to emphasize it is favorable, write it here, favorable. Here, since we got the answer minus, you can say this is adverse. Done. Material yield variance. Standard input to output. What's the mix they have given, or what's the ratio they have given? if you give 20 plus 15 plus 10, 45 grams of input, 45 grams of input, you will get how many units of output, the standard materials usage and cost for 1 unit or 1 packet. So this will give you 1 unit or 1 packet, 1 unit or 1 packet. Total actual input, altogether how much of input has been given. I have it here, 4650 kilograms, 4650 kilograms. So from this many input, this many kilograms of input, what was the actual output? 101,000 units were made. 101,000 units were made. So from 4650 kilogram, 101,000 units have been made. So what is the expected output from actual input? Expected output from actual input. You can see every 45 grams you will get 1 unit of output. Every 45 gram 1 unit. So I have given 4650 kilograms. This is in kilograms. So let me multiply that by 1000 to convert that to grams. So this many grams have been given as input. Divide by 45 to find how many units we can expect from this, because every 45 grams 1 unit could be expected. So 103,333 units could have been expected. In other words, the input you have given is sufficient to make 103,333 units, but you have given only 101,000 units as the output. So effectively the difference, that is 2,333 units input, has been wasted in the process. Let me say again, 2,333 units input, material input, has been wasted in the process. So let me get the difference. This minus this minus 2,333. You multiply this by alright, so this difference is this many units. Multiply this by standard material cost per unit of output, which is already given to you, $1.10. Here it's given $1.10. Multiply the difference by this, you will get the yield variance, material yield variance. This multiplied by 1.10, which is 2,566. You get a minus answer here, so which indicates adverse variance. You can do a double check. The total of mix variance and yield variance has to be equal to the total usage variance. Let me do a double check. This is the mix variance, this is the yield variance. Adding together, you should get 1,150 minus, correct, that is the usage variance we got. So it tallies. 4 marks, 4 marks, 4 marks, 12 marks have been confirmed with this much of work. So this is nothing new for us. We have done so many questions like this, and this is one of the routine type of questions. If you are facing a F5 exam, you must be expert in doing this calculation flawlessly. There can't be any problem you could have in doing this calculation when you're going for a F5 exam. If you are unsure about doing this calculation, then you are not fit, you are not prepared enough, you are not practiced enough. Why I selected this question is actually for the section B, part B of this question. Calculate the following activity-based variances in relation to the setup cost of the machines. The expenditure variance and efficiency variance. So this expenditure variance and efficiency variance, let's connect it to the variable overhead expenditure variance and efficiency variance, because variable overhead is somewhat similar to this. In variable overhead, what do we say? Based on labor hours, the variable overhead changes. More labor hours are worked, you get more variable overhead cost. This machine setup cost is also something similar to that. You do more and more machine setup, you're going to get more machine setup cost. So like labor hours we have for variable overheads, here the driving factor, the measure that drives the overhead cost is number of setups. So in a variable overhead expenditure variance, how do you do the working? You take the standard hours for actual production, actual hours taken, you get the difference, and then you multiply it by, so you get the difference, standard hours for actual production, standard hours for actual production, actual hours, you multiply by standard expenditure. What do you mean by standard expenditure? For 1 hour, how much of variable overhead cost is expected? Let me apply this concept here. Machine setup cost, expenditure variance, right? Like standard hours, what are we going to have here? It has to be standard, not hours. Here it has to be number of setups, and this column has to be actual number of setups, and you're going to multiply that by, the difference will be taken, multiplied by, here we multiplied by standard expenditure, here we are going to multiply by standard cost per setup. Okay, it was standard cost per hour, right? Because the difference was taken in hours, so you multiply by hourly cost. But here, the difference is going to be taken in number of setups, so you multiply it by cost per setup. I repeat again, variable overhead expenditure variance, how do we take? Why am I talking about variable overhead expenditure and efficiency? That is what is comparable to this machine setup cost, expenditure and efficiency. So I'm taking a comparable known variance, and then from a known variance equation, I'm deriving the formula for an unknown variance. In variable overhead expenditure, hours is the driving factor, labor hours. In machine setup cost, it is number of setups. So there I use standard hours, here I am using standard number of setups. Actual hours, actual number of setups. Standard cost per hour, standard expenditure you call it, here standard cost per setup. Right, let's see how to get the standard number of setups for actual production. Remember, standard hours means standard hours for actual production. So here also standard number of setups or expected number of setups for actual production. What information they have given? See, for 264,000 units they produced, 330 setups were expected. So let me do another calculation here. Number of units per setup. 264,000 units in 330 setups. So per setup 800 units are done. So when you make 320,000 units, actual production is 320,000 units, how many setups should have been done? Every 800 you make one setup, so 320,000 divided by 800, 400 setups you should have done. Whereas actual number of setups is only 360, they have given 360. Standard cost per setup, 52,800 is the standard cost for 330 setups. So you take 52,800 is the expected cost, that is for 330 setups. You divide per setup cost, standard expected is 160. So the expenditure variance has to be bracket standard number of setups minus actual number of setups multiplied by standard cost per setup. You must excuse me guys, I made a mistake here. This is the formula: standard hours, actual hours, standard expenditure. This is the formula of variable overhead efficiency variance, not expenditure variance, efficiency variance. Efficiency variance. So here also it has to be machine setup cost efficiency variance, not expenditure variance. Done. So repeat again: variable overhead efficiency variance, hours difference into rate. Machine setup cost efficiency variance, setups difference, number of setups difference multiplied by cost per setup, standard cost per setup. So you get a positive 6,400 answer, which indicates favorable. Now we'll see how to find variable overhead, machine setup cost expenditure variance. For that, let me take variable overhead expenditure variance, which you calculate as standard expenditure minus actual expenditure multiplied by actual hours. Standard expenditure minus actual expenditure multiplied by actual hours. That's for variable overhead, usual variable overhead. So machine setup cost in this case, machine setup cost expenditure variance has to be standard. There we say expenditure, here it has to be same expenditure but cost per setup. There cost per hour, actual cost per setup. That is what you can call as expenditure. Actual hours, there it is actual hours, here it has to be actual number of setups. Actual number of setups. Then we get the answer. Standard cost per setup, we already have it here, 160. Actual cost per setup, let me check here. 360 setups, the cost has been $60,000. 60,000. So 60,000 divided by 360. So on average it is 166.67. So it's obvious, you can see per setup you expected $160 cost, but actual cost has been 166. You have spent more, $6 more. Multiply this by number of setups, actual number of setups, which is 360. Just given 360. So the variance has to be standard rate is 160, actual rate is more than that, so you are going to get a minus variance, which is adverse variance. 360 setups, 2,400 minus. So machine setup cost efficiency variance. I did not study a separate equation for machine setup cost efficiency variance. What I have done here, I took variable overhead efficiency variance. From that, I derived a formula for machine setup cost efficiency variance and got the answer. Finally, if you don't like this, if you don't want to leave this because this line seems unrelevant for the answer, you can delete it. Even if you leave it there, no problem. The marker would understand, okay, how you have derived this formula. Similarly, machine setup cost expenditure variance, I'm deriving from variable overhead expenditure variance because this is a known variance for me. This is quite a new variance for me. So I'm deriving a formula from a known formula to an unknown formula. Right. So now you may have a question. Activity-based costing is not tested in section C. Do I have to study this? Is it possible to come in section C? Answer. First point you must understand, activity-based costing as a costing technique, it may not be tested in section C, but the flavor of activity-based costing can be included in a budgeting question or standard costing question like this. There is no confirmation from the examiner that it will not be tested like this. That is point number one. Point number two, This kind of question can even be tested in the first part, section A of the paper. One of these workings, say they can give this information and ask find machine setup cost efficiency variance for a 2 marks question. So you must be fit enough to find up or come up with your own equation like this and answer. So please don't exclude this kind of working. It can come in any part of the paper, section A, section B, section C, anywhere A, B, C and stand costing can be mixed together and a question like this can be tested. Briefly outline the steps involved in allocating overheads using activity-based cost. This question is purely a costing technique question. In section C, it won't be tested, but in section A or section B, they can give the steps in a different order. And they can ask you to number them in the correct order. Every faculty would have given this in your notes. Every book has these steps, and they say briefly outline. You don't have to even explain the steps. Just state the steps. You get half a mark per step, 2 marks. So steps in ABC. First one, identify the activities that generate overhead costs. Second one, identify the factors. Second one, estimate the total overhead of each activity. Sometimes you can bundle these 2 steps together and say one step, identify the activities and the total overhead of each of them. Then the next step has to be identify the factors that drives the overhead of each activity, which is actually cost driver. Calculate the cost driver rate for each activity. Using the cost driver rates, estimate the overhead cost of each product. These are the steps. Sometimes a couple of steps can be bundled together. These 2 can be bundled. Sometimes these 2 can be bundled. Find the cost driver rate, and using the cost driver rate you find the cost for each product. That kind of combinations is possible, but then all 5 points should come in your answer to get these 2 marks. Alright guys, so this is one good question on ABC. I thought it would be useful for you. Please revise it. Thank you.